Hello. How are you? Are you still, are you tired already? Ready to stop? Shall I work with this one? All right. So, yeah, hello. Can you see my screen? Yeah, let's make it a little bit bigger. Where is it? Display. Okay. Scaled. Yeah, that looks good. All right. Hello. So, as said, my name is Simon. I'm a solutions engineer at Edgenode. That's one of the core dev teams that works on the graph protocol. Quick question, who of you knows what the graph protocol is? All right. Who of you has ever written a smart contract? Oh, okay, now it gets better. And who of you will hack on ETH India this weekend? All right, cool. So I give you right now some tips how you can get quickly started on ETH India and how to make a quick thing. So like the graph is sponsoring ETH India, so we have a complete overview of prices, $7,000. New is that we have like a pool price, so if you just follow these steps that I show you right now, you will be eligible for the pool. That's actually a quick win, right? So there's also this presentation, you can scan this QR code to follow along, because I have like, actually there are 3 sections. So the first section is very quick, how you can make a subgraph in 5 minutes. Then the second section is how you actually build a front end on top of it, which is a little bit more complicated and probably hard to follow in that short amount of time. And then if we have time, we can dive into what the graph actually is. But let's do it like this, right? So when you are at the hackathon, at some point, probably Saturday or so, you were finished with writing your smart contract, it more or less works, and now you need to build a front end, right? So you have deployed your contract to Arbitrum girly and start to interact with it, and then you realize you need to write the front end on top of it, otherwise you cannot present anything, right? So what you usually do, people, they go and then use the so-called JSON RPC interface. The JSON RPC interface is a way to interact with an Ethereum node, but the problem with it, it was never meant to be a data standard to use in a front end. So you will start to write like very ugly code like this, because you'll go back and forth with calls, and all these calls take 200 or 300 milliseconds to resolve. And in this code, it's a very simple website where you just want to show the NFTs that someone has and maybe some metadata. And that could, if someone owns 10 NFTs or something like that, it can take up to several seconds to just load that page, right? And I mean, usually people nowadays are very nervous, so if something loads more than 300 to 500 milliseconds, they just move away, right? They go back to Twitter and distract. So what do we actually want to have is something like this, like a very beautiful GraphQL query, where you have like, where it's structured and you can get all the data in one request right to your front end. But the question is, how do you do that? The solution is actually the graph. So I'll show you quickly how you can do this. So usually you are here, most people start to work in Remix, right? So in Remix, you can very easily make a new workspace. Then you say like, I make an NFT, it's mintable, burnable, pausable, whatever. And then you just click OK, and you have it generated for you. Let's say it's the Bengaluru token, BTK. And yes, and you already have your token contract. Maybe you edit a little bit, we don't need this before token transfer actually. And yeah, that's a very simple token, only the owner can mint. So yeah, that's it. I mean, now we can compile it, and maybe it works. Yeah. Cool, so we have compiled the token contract, and then we can go here and deploy it. So we go here, and we take the injected provider. Cool thing about the injected provider is we can deploy to any chain we want. Let's try to deploy to Arbitrum girly testnet. All right, so I already have some ETH here. So Arbitrum Girly is the testnet from Arbitrum that we heard before about it. So that's actually simple. Let's just do this. We don't need to do much here. I can just public deploy. It asks me to spend some ETH, but since this is a testnet, that money doesn't really make a difference. Boom, and here it is already, right? So we have it deployed. Let's check. We should see, yeah, a transaction hash. So we can go to rbscan. I think it's girly.rbscan.io. And check that transaction. Nice. So we now have a contract deployed. That's very cool. And that's where we were before. So, but now, how can I get data out of this deployed contract? So the trick basically is to verify the contract. So you click on the contract, and then you go here, and then you say you want to verify. Right. And then when you start, you say the compiler type, it's Solidity single file. Then I get the version, which is 0.8.7. You see this here. Here we compiled with 0.8.7. Cool. And then open source license, you can just choose one, continue. And then you need to paste all your Solidity contract code here. Now the problem here is because we have some imports, it's actually quite tricky, but I mean, there's a simple trick. You can just go here and get the flattener, activate the flattener, go over and just flatten it, and now I have it in the clipboard. I mean, that was 2 clicks, right? So I can paste it, and everything is here. I just say that I'm not a robot. Maybe I am. And boom. Verify and publish. So now we have already the contract verified on Girly, Arbitrum Girly. So the next step would be to really now use the graph. So how to use the graph? You just go to thegraph.com, and if you are working with any chain other than Ethereum, mainnet, or actually Girly, you go here in the product to the hosted service. Otherwise, you go to the Subgraph Studio. So, but since we are on Arbitrum Girly, we go to the hosted service. I need to sign in. All right, I need to go do this in this browser, actually. Hosted service. Here I'm already signed in, so you just sign in with GitHub. You go to my dashboard, you add a subgraph, you say the chain that you want to index. Arbitrum Girly, here we go. You give it a name, let's say Bengaluru token. Subtitle, hide it, great. So now we created the subgraph on the hosted service. Now here you have like the next step that you need to do on your local machine to actually be able to deploy the graph. So you install the graph CLI globally. I already did that. You could check this if you run graph -- version. The version that we need is 0.361. And then you basically just do graph, you can just copy paste it over. Boom. Then we say the protocol is Ethereum, the subgraph name is Schmid/Bengaluru token. This is my GitHub username. The directory, you can just go with this. And then we here check. I think for Arbitrum Girly, we didn't update the thing, but it should work. Let's see. Otherwise, we can also go into deep. So we can go back to the contract address, copy the contract address, and paste it. Right. For some chains, this doesn't work, but don't panic. Actually, all we need to have is the ABI, and the ABI is here. So we can copy the ABI and create a new folder here. Just create a file. Just 1 second. It's token.abi and paste. So important here is that this thing is at the same folder. See, I have it here, token.abi. So I can just say token.abi. Contract name. And then this is also very important that you just say, I want to index all the contract events as entities. That helps us to quickly bootstrap the subgraph. So now the subgraph is generated in the background. We can already have a first look at it. If we go to that folder, Bengaluru token, we can have a look at the subgraph. So the subgraph basically is a Node.js project. You have a package.json. Here you have some dependencies and some commands. We will later look at those. But there is one important thing. The first thing that I look at is the subgraph YAML. This is the manifest. It says which chain do we index, which is the address, where is the ABI, and so on and so forth. And also the event handlers that we want to index. So what the graph does is it actually watches the chain for events, and then the event handlers get triggered. But the cool thing is this is now already auto-generated for us. So we have a schema, and you can think about the schema as a database schema, where we have for every possible event, we have a table where these events are stored, and then we have the mappings, and the mappings are just storing that stuff. But we don't need to actually know what's going on. We can just move on with these instructions here, and can run this code. And then run this one. So we need to authenticate, and then we can just deploy. Okay. So I think because we didn't update this, I need to forward this. We need to switch here to Arbitrum girly actually. Let's try again. Woo! Nice. We already have now our subgraph deployed that indexes the data from the token that we just published. See, now there's one thing. It starts at block 0, but we already have 2 million blocks in Arbitrum girly. So what we need to do is we just tell them like where to start. It doesn't make sense to start at block 0. It's actually easy. We can just go back to the token, to the contract, go on the creation transaction, and then copy paste the block number out. We go back here, and in source addresses, we add the start block. All right. Same thing again. We do graph codegen, graph build, and then graph deploy. Cool. And if we do this, then it automatically updates here on the hosted service, and you see now it's already synced. That's nice. But we don't have any data in that contract yet, right? So let's create a quick mint. So again, on Remix, you can just go in here and start to interact with your contract. So let's mint one. I can mint one to me. And then specify the token ID. Actually, open this a bit. Zero. We can also look at this thing here. So the GraphQL, who of you knows GraphQL query language in general? Not that many. GraphQL is not so popular here. So I show you about GraphQL. What's very cool is like you can auto-inspect what's going on actually. So here, when you open this URL, you receive this Explorer, and in the Explorer, we can look into what we have here. So we can just try to transfer, we get all the transfers. And I can just quickly, I don't really need to understand how GraphQL works. In the end, you send this query to the endpoint, and then you receive a JSON back, as here. But right now, because there are no transfers on that contract, it is empty. So now we can create the first NFT. So let's do this. So I click here on transact. Where are you? Maybe it's too much. Okay, let's try again. Maybe I killed it. Let's refresh it. All right. We have still the thing here. And now I need to go again with my injected provider. And in this, I need to link the contract again. So I get the contract address, go back here, and I say I want to actually interact with that one. Let's see. What I'm doing wrong here. It's the first time that my demo doesn't work. Okay, I have the contract address. Maybe I need to compile it first, yes. Okay. Let's try again. Yes, here it is. Cool. Again, let's try save mint. I mint it to myself. Finally. And yeah, now I mint one token to myself. Boom. Now, you see the token is minted. If we go to that contract, we see there is a second transaction on the contract. And if we go back to the graph, and I send this query again, then we see the transfer is registered and it's GraphQL. It took me maybe a little bit more than 10 minutes, some hiccups, but roughly, I would say it's very easy to, when you have a contract developed on Remix, to move it to the graph and have this GraphQL interface to interact with it from a front end. I don't know where we are with time. I think I can do another 10 minutes. Cool. So to summarize what we did here, this was the battle-tested one. So you can publish a contract or deploy a contract to any network. You can flatten the contract then to be able to verify it. Then you go to the graph, you create a new subgraph, you follow these instructions that are there when you follow it. It will be similar to the studio and hosted service. You install the graph CLI if needed, then you just run graph init or the stuff that is written there. You change the start block, that's very important, and then you deploy, and you already have like a subgraph that indexes your events. Obviously, you can then start to extend it. You can go to the schema. Oops. Yeah, you can go to the schema and say like, I don't want these entities or whatever, or you can go to the mapping and start to make it more complex. But as a good starting point, and if you do this during the hackathon, you will already be eligible for the pool prize. Cool. Yes, so the next would be the bleeding edge local dev, but I think since I understand that a lot of people here do not really know what is the graph, we skip that, and we just go a little bit over the basics. So what is a smart contract in general? So you can think about a smart contract as data storage similar to Google Sheets, right? Where you have rows, and in this example where we look at the CryptoPunks, you have just the ID and the owner. That's what is there in the contract. The contract by itself doesn't necessarily know about who owned it before, right? So it has the current state and some rules how to change that state. So for example, one rule for NFTs is only the owner can send the token around, basically. That makes it so interesting. Very simple. But as I said, so what's about the provenance also? Like, what about that data? How can we access that data? Wouldn't it be nice to have like a time machine where we can go back in time and see the contract state, how it was before? And also like a very easy way to create a current contract state. So with each transaction, someone changes the blockchain, and by changing the blockchain, the state will be changed. And but every transaction is laid on top of each other, so you basically can always go back, and that also gives the security. You always know what was going on before, right? But there are a lot of problems. So initially, we had this idea of having fully decentralized apps like dApps, where you have a user interface deployed to IPFS, or now Arweave that interacts with a blockchain like Ethereum or Arbitrum or Polygon or whatsoever. But as I said before, like the problem is writing to the blockchain is actually quite easy because every miner is very interested to mine your transaction because you pay gas fees, but like nobody's really incentivized to deliver you that data. That's why we see a lot of RPC providers coming to the space that do it in a centralized way. That help actually fill that gap, but we want to have another solution here. So, as I showed you before, like you end up writing that shitty code, but what would be nice is to have like an indexing protocol in between that sits between the blockchain and your user interface that not only can display the current state from a current blockchain, but maybe from all the blockchains and also different data sources. For example, with the graph, you can index Ethereum, Polygon, Arweave, IPFS, Arbitrum. So it really helps you to combine all these different data sources into your front end. And so in the end, we end up with this very cool, nice query here. So as I said, like the graph is these APIs for a vibrant future. We have currently more than 1 billion queries per day on the hosted service, and we are moving those like slowly but surely to the decentralized indexing network. There are more than 224 indexers worldwide. We will be currently onboarding more indexers, and these people that run these servers or these indexers are individuals. That means that they do not belong to any foundation or entity altogether. That makes it very resilient, and they are distributed across the world. So when one goes, or like wherever you query, you get a response from the most nearby. But when one goes down, another one jumps in. So this actually makes us moving towards this global open API, and that enables us to write truly decentralized apps. Yeah, we looked at the subgraph already. We can go again, like small repetition. A subgraph defines a database schema. It defines some rules, so-called mappings, how to extract data from the blockchain and store it in that database schema then. And in the end, it provides a simplified layer to query that data. So on the blockchain, the problem is like you have all these transactions from the different protocols all stacked on top of each other, and if you want to make sense out of it and want to see like what happened in which protocol, you need to organize this a little bit better. So in the end, you can think of subgraphs like this. You write one subgraph that has like one protocol in mind, and then you have like this clear separation of data and concerns. And so in the end, how it works, you have a dApp on top that sends transactions to the smart contracts, which get indexed by the graph node, which then runs a mapping and stores it in the database in the bottom right. And if you want to query it, then you go through the left, and then you have queries which go to the GraphQL API and then back to the graph node. So in the end, this is maybe a little bit what the subgraph does. It takes that mess of all these different transactions and orders it in this very beautiful way. So now, if you want, you can tweet about that you learned about subgraphs, but I think I'm also closing here. If you have any questions, I'm here. I will also be at the hackathon. We have a good team there, so if you have any questions, if you're stuck, if there are any problems, feel free to just reach out to us. Maybe a last slide that I can show you is this one. So if you want to go into subgraph development, if you have any questions or anything else, like this is my Twitter, you can scan it, my DMs are open, you can always write me, you can come to our Discord, and we will help you to get started. All right. Thank you so much for your time, and I hope you have happy hacking.